Okay, so this is a supplementary part, a second part to the video on exponential and trigonometric function differentiation. So we went through the derivatives of sin x, cos x, tan x, e to the x and log x, as you see up here. And I realized that there's at least one thing I missed from the video. I'd like to go to show a few more examples, especially of integration, because what we did in many of these problems is we relied very heavily on the knowledge of the chain rule. We don't have the same rule in integration. This is a misunderstanding students often have, but we have something very similar. And let me just go through some key examples. Now, a lot of this you should be familiar with if you've done P1. So a problem like this you can solve using the method of P1 chapter 16 section 7. So I'm referring to the part of the textbook there. And the method of solving this kind of problem is based on a general formula: integral ax plus b to the power n dx equals 1 over n plus 1 times a and ax plus b to the power n plus 1 plus a constant. Now, the idea behind that method is really what's called integration by substitution. It's based on the idea of saying, well, if u is equal to ax plus b, then du by dx is equal to a. And what we can say roughly is that du is a dx. Now that's a bit silly because they're not numbers, but it's a bit like saying a small change in u is about a times a small change in x. And that's true if you think about it. So although I haven't really explained it in detail, what it means is we can change this integral into an integral in u, because ax plus b is u, and dx is the same as du over a. So this is u to the n plus 1 over n plus 1 times a. And this gives us the formula we just said. So this gives us the formula we've just stated up here. So going back to the original example that I mentioned, you should already know that this is 1 over 3 times minus 6, 3x plus 2 to the minus 6, or minus 3x plus 2 to the minus 6 over 18, plus a constant. Okay. Okay, so now let's think about cases like this. The derivative of sine 3x. What's the answer? Well, using the chain rule we could write u equals 3x, and we can easily calculate that d by dx sine 3x is 3 cos 3x. So I don't want to look at too many examples like that. You should be able to do anything of this form. For example, tan pi over 7 minus x. The answer to this would be minus sec squared pi over 7 minus x. check that you understand that. Now let's think about integration. Suppose we were trying to integrate something like 7 sine 6x plus pi over 3 dx. Well, here what we would do is follow exactly the same logic as I showed you here. Well, I should say here, right? Which is to make a substitution u equals 6x plus pi over 3, so that du is equal to 6 dx. And this would give us the same kind of formula as before, see if you can get the right answer. It's minus 7 over 6 cos 6x plus pi over 3, and don't forget the constant. So what general formula will we be using here? We'll be using the general formula integral sine ax plus b dx equals 1 over a times minus cos ax plus b plus a constant. What's the equivalent formula for cosine? Well, that would be 1 over a sine ax plus b plus a constant. And you can write the same kind of formula for any case where you have a composite function and g of x is equal to the integral of f of x dx. It will always work. So because it will always work, it will also work for e to the x. What's integral e to the 4 plus 2x? Well, using that formula, I'm going to get 1 over 2 e to the 4 plus 2x plus a constant. And that's correct. If you like, you can check any of these formulas by differentiating the answer. The derivative of 1/2 e to the 4 plus 2x plus k equals half of the derivative of e to the 4 plus 2x plus the derivative of k equals half e to the 4 times the derivative of e to the 2x plus the derivative of k. That's e to the 4 over 2 times 2e to the 2x plus 0 and that's giving me e to the 4, e to the 2x, or e to the 4 plus 2x. And this answer is the same as the original function, so the whole process was correct. Okay, so you can see all these ideas follow the same basic pattern. But I want to give you a big warning. don't try and apply this principle in this case. Some people think that the answer should be 1 over 2x sine 2 plus x squared plus k. But that answer is wrong. And it's not completely obvious at first why it's wrong. The reason it's wrong is because this process of making a substitution, which we outlined here, simply does not work in this case. If we wrote a substitution u equals 2 plus x squared, we would have du equals 2x dx. So here I'm differentiating x squared to get 2x. So in this original formula I would have to replace dx with dx equals du over 2x, and I would get integral cos u times du over 2x. And you see here we're writing integral cos u du over 2x. Well, x is actually u minus 2 and the square root. So this would be something like integral cosine u over square root u minus 2 du. And let me put a big question mark here. So that's connected to that. So big question mark here. Why? Don't know. We don't know how to do this. It's very, very difficult. And I can tell you that integration is sometimes a very difficult process. So solving a problem like that could be very difficult. But notice the key difference. When we did it up here, du was 6dx, which meant we just had to divide by a number 6. So what you need to remember is that in this case here we cannot use the same principle, and the reason is because the inside function is not linear. It's not of the form ax plus b. And if it's not of the form ax plus b, then this same trick that we played here to get this general formula will not work. So I hope you understood that principle. It's very important. You should have already learned it in P1 in regard to powers of x, but it also applies in all these other cases. So to finish off this video, let's just look at a few examples to test you. Let's do e to the power 3 minus 5x dx. What's the answer? The answer is minus e to the 3 minus 5x over 5 plus k. Okay, let's try another one. What's the derivative of the logarithm of 16x minus 7? The answer is 1 over 16 times 1 over 16x minus 7. And let's just, so that's the answer to the second case. Sorry, that's stupid. I managed to confuse myself there, so little test for you if you notice that was wrong. Of course, here we're differentiating, not integrating, so we're applying the chain rule, and applying the chain rule will give us 16 times this function. Just to confirm that, you can write u equals 16x minus 7. So du by dx is 16. So dy by du times du by dx is 16 times 1 over u, which is 16 over 16x minus 7. So that's differentiation. It's the opposite process. Let's look at another integral. Integral of sec squared 5 plus 2x. Well, that one will be tangent, because the integral of sec squared is tangent. 5 plus 2x, but we need to divide by 2 plus a constant. And I've just remembered I made a silly mistake up here somewhere. No, I didn't make a silly mistake. Yeah, that was a derivative, so no panic. Okay, so that's a good one. Let's try another one. Let's try the integral. Now, how can I make this interesting? Okay, let's try the integral of 1 over the square root of 2 minus x divided by 7. So that's a square root dx. What's that equal to? Think about it. Okay, so you should notice this is a power 2 minus x over 7 to the 1/2 dx. Now remember the general formula. Let me write the general formula here. Integral ax plus b to the n equals 1 over n plus 1 times ax plus b to the n plus 1 plus a constant. So applying that rule, I get 1 over 3 over 2 times minus 1 over 7 times 2 minus x over 7 to the power 3 over 2 plus a constant. Tidying that up, we get minus 14 over 3 2 minus x over 7 to the power of 3 over 2 plus a constant. So it looks complicated, and it is a little bit more difficult, but it's the same basic pattern. Okay, let's try maybe one more. Integral cosec 3x over 2 cot 3x over 2 dx. And I'll evaluate this between limits pi over 4 and pi over 3. Obviously this is a bit more difficult. If you've got a good memory, you might recognize this was one of the results we determined earlier on up here. Cosec x cot x was the derivative of cosec x. So here the inside function 3x over 2 is linear. It's of the form ax plus b, with a equals 3 over 2 and b is 0. So we can apply the same principle. This must be minus 1 over a, which is 1 over 3 over 2, times cosec of 3x over 2, all evaluated between pi over 4 and pi over 3. Remember, we must use radians for calculus. So let's tidy this up. We have minus 2 over 3 times, the first evaluation is at pi over 3, cosec, this may not actually work because the answer may be infinite. Cosec pi over 2, and then if we put pi over 4 we get cosec 3 pi over 8. So this is a problem, I think, because no, sorry, it's not, is it? So I have minus 2 over 3 Now sine of pi over 2 is 1, so cosec pi over 2 is also 1. And sine of 3 pi over 8, I don't know. That's sine of what's pi of 45 plus. Okay, so it's not an obvious number. Let's just write it as 1 over sine 3 pi over 8 equals ... Use a calculator. You'll get a certain number. Okay, so that example was difficult. I don't think you'll see that in an exam without some extra help maybe. But those are the kind of ideas you need to apply. So I hope that was helpful. I'll leave it there. Thank you very much.